Hello, everyone. My name is Abdulakim Yusuf Ademola, and I am an undergraduate student at University of Ibadan. I'm here to discuss and to expose us to MongoDB 101. What are the things that you are supposed to understand about MongoDB, and what are the benefits for students participating in MongoDB? So I'm going to be sharing my screen now. We are going to be starting with the MongoDB 101 non-relational for beginners. So overview of non-relational databases. What are the things that you are supposed to know about MongoDB concerning the non-relational databases? Where it begins. When we're talking about relational database, we are talking about a database that can store rows, that can store data in rows and columns. That is in one table, using SQL, that is structured query language, to get some of the information that you want to use. So a table uses colon to define the information, as we all know that we have the row and the column. So the row and the column has each of them has what's the specific things that they are being used for. So to understand non-relational databases, that is NoSQL databases, we first need to look at SQL database. Sorry, the network. So to understand non-relational databases, that is NoSQL databases, there are things that we need to understand. That is, we have to look at the structured query language or relational databases. So relational databases are modeled similarly to an Excel spreadsheet. That is, a spreadsheet that has a row and a column. And the SQL language, the structured query language, is the most common way of interacting with a relational databases. That is why most of the developers have the opportunity to write their SQL queries to perform operations like create a table, to read a table, to update a table, or to delete a table. So relational databases since 1970s was developed by IBM as a way to interact with new relational databases. By the time it's reached to 1990s, we have World Wide Web, that is for data storage explodes. By 2000s, we have NoSQL, that is unstructured data storage. To unstructured data storage is a kind of data storage that is being used to store a large amount of data in order to mitigate costs and increase efficiency. So when the traditional relational databases were introduced, where they were able to handle the growth of the data size by running on bigger machines. But when the web came, a huge data explosion that made it difficult to scale with hardware. So you could not scale the database by running it on a bigger server. So that is why most of the components, they are horizontally left to scale by distributing data across multiple servers. So that's why we have there's some scale options which were often complex and costly to maintain. We have the relational databases. So to mitigate the cost of the first navigational databases and allow for searching, so we have the World Wide Web and we have NoSQL. which was created to allow for faster processing of larger, more varied data sets. So to fix this problem now, there are different technologies and software companies that have introduced new databases referred to as NoSQL or non-relational. So what is a non-relational database? A polymorphic data structure. What is polymorphic data structure? That is, we're going to be discussing this. Something that is flexible, that has flexible schemas and easy to scale large workload. So that non-relational databases differ from relational databases in that they do not store data in a tabular form. That is why it is different from relational databases. So instead of non-relational databases to store data in form of tabular, in form of table, so it might be based on data structures like documents, graphs, or dictionaries. So NoSQL databases also come in a variety of types based on their data model. And they provide flexible schemas and they scale easily with large amount of data and high user loads. So what are the types of non-relational databases that we have? We have key or value, we have graph, we have column, and we have document. These are the four main types of non-relational databases that we have. Let's dive into key or value database. A key or value database has a structure of which has a unique key that is paired with a collection of values. So the values can be anything from a string to a large binary object, and it has a simple data model. So look at this example now. This is the key, the name, the value. The key, the age, this is the value, and the address, this is the value. So as the simplest of the non-relational database, key or value is exactly as it sounds. So data is organized based on an identifying key and its corresponding value, as we have explained earlier there. So which structure? Now let's go to the graph database. What structure does it conform with? It captures connected data, and then each element are being stored as a node, and there's a connection between nodes. These connections are called links or relationship, and it has a traversing the connection between data. Address. We have graph example here now. We have address. We have John Watson posted. Look at the interlink there. So there's a rudimentary example of how data could be stored in the graph database. So as you will see now, so this type of store now is used for social media application. So where multiple objects will have multiple relationship, schemes or links. Now let's dive into column-oriented or wide column. A column-oriented or wide column is it has a structure whereby data can be stored using key rows that can be associated with one or more dynamic columns, and is highly performant queries, and it is also designed for analytics. So now we have Cassandra now, which is a commonly used column-oriented database. And the advantage of column versus record or row-oriented database is that column-oriented database return data in columns, making the query much more performant. That is, it performs well. It's not going to return so many irrelevant fields that are not required for the query being serviced. Look at the example now. The name, we have the age separated and the height separated. So, document database, it has a polymorphic data model, and each document contains markup that identifies fields and values. So, and it has an obvious relationships within embedded arrays and documents. We have nothing like complex mapping in document database. So document databases such as MongoDB, store data in a single document, which can have different shapes within the single collection of table. It has a clear means of capturing relationship using documents and embedded arrays within a single document. So look at document model example now. The object ID, the user ID, the age, the country, city, streets. So this is a kind of example of document model. So what you need to understand about document model is that data that is accessed together is stored together. So it is also important to know that just because we have one document and that has a one field does not mean another related document has to have the same field when stored together. So now let's go to the document model now. For general purpose use, the document model prevails as the preferred model by developers and database administrators. Because due to the fact that it uses a programming language, it is preferred mode. It is the preferred model by developers, and because it's most closely matches the way they think and the work. So we'll explain how it functions. So for more information, you can go to the link here, and you're going to understand more about MongoDB. Let's click on the link.
MongoDB is based on the document model, a fundamentally different model than traditional relational databases. The document model is the key design choice we made, and it's why developers love working with MongoDB. Let's walk through what the different models look like in practice. A relational database is fundamentally Microsoft Excel on steroids. Both are made of rows and columns, organized in tables or sheets. Let's say we're building a patient record-keeping system for a doctor's office, and we're going to build it in Microsoft Excel. First, let's look at a small piece of that system, the contact information for the patients. Simply enough, with a sheet that has a row for each patient. That row has a unique patient ID number, their first and last name, email address, phone number, and home address. But what if we want to add a second phone number for the patient? Maybe their work number, or their cell phone number, or even an emergency contact number. We could just add more columns, but the same issue comes up for addresses. And even patients will eventually load it empty inefficiently like this. So instead, in our Excel model, we'll create a separate sheet for phone numbers. Each row in that sheet is just a phone number, the patient ID it refers to, and the label icon. We'll do the same thing for addresses. We already need to go to 3 different sheets just to look at a single patient, and we're only at the tip of the iceberg and haven't even thought about any medical data yet. Add in more sheets for medications, more sheets for office visits, more sheets for emergency contacts, lab results. You can see how this gets out of hand quickly. This is exactly how developers work with data in relational databases. In real-world applications, it's common to have the data for a single thing, like a patient, spread out over dozens of tables. This has a massive amount of complexity in the application. There's 3 big drawbacks. The first is that it's just frankly hard for people maintaining the application to understand. Second, it makes adding features harder because there's so much more to account for. And third, pulling data. This was not real. And the doctor's staff had to pull names from one cabinet, phone numbers from another, and addresses from yet another cabinet. You can see how complicated or prone and slow that would be. MongoDB takes an entirely different approach. Data is stored in people. Just like physical medical records, one patient's they can have 3 phone numbers, 2 addresses, 20 prescriptions, and it can live right next to another patient document that only has 1 phone number, 1 address, and no prescriptions. Records aren't restricted to having the same number of columns. Documents let you structure data in a way that is efficient for computers to process and natural and easy for humans to read. This is incredibly powerful for developers because they don't have to make their applications accommodate the needs of the database anymore. MongoDB accommodates them so their applications can store data in a natural way. It also means that they can adapt, add in new data when they need to, without worrying that a simple change is going to break everything. In addition to the document model, MongoDB is fundamentally different from legacy databases because it natively knows how to coordinate multiple servers to store data. That makes MongoDB something called a distributed database, and it allows MongoDB to provide 3 features that developers and architects would otherwise have to build themselves, saving them massive amounts of risk and work. First, natively built into MongoDB by keeping redundant copies of the same data on different servers. A single server failure doesn't affect the application. Second, MongoDB seamlessly scales across multiple servers to store and process data. As data volumes and performance requirements grow, you can just add more servers instead of upgrading to million-dollar mainframes. This is also great for cloud environments, for spreading load across machines and for the customer. And third, lets you move data to where you need it, so you can keep data near users around the globe for fast access. The combination of MongoDB's document model and distributed systems components is what gives MongoDB such an advantage over relational databases. Beyond offering the leading modern database, we've also built management tools to help operations teams provision, configure, secure, monitor, backup, restore, and upgrade MongoDB clusters. This is critical to making MongoDB suitable for the most demanding use cases and for organizations with strict SLAs and operations requirements. We designed MongoDB for the cloud, and MongoDB has been widely deployed in the cloud for some time. But more and more customers are interested in building their applications with components offered as a service. To meet this need, we released MongoDB Atlas, our database as a service offering. Atlas enables our customers to consume MongoDB as a service without having to worry about managing the database. MongoDB Atlas is available on the leading cloud platform, Amazon Web Services, Microsoft Azure, and Google Cloud Platform, giving our customers the flexibility to select a public cloud provider of their choice, avoiding vendor lock-in, and without having to rewrite any code. These innovations are driving more and more organizations to adopt our platform.
Oh, thank you everyone for following the YouTube video. So that's what we need to understand about MongoDB. So these are the key features. We have the API query or query language, then distributed and resilient, flexible schema, and then the objects mapping. So this is the document model structure and syntax. So this is the user ID, the age, and the status category. Under structure. So each field must be enclosed within quotation mark. That is, this quotation mark must be there. And each field in a MongoDB document must be enclosed with quotation marks, as I've said earlier, because strings values are often quoted as a good practice. And each field value pair is separated within documents by commas. This is a comma. Each document, comma, this is the ID. That has to be separated by comma. So now let's go to collections in the document model. Document is a kind of way to organize and store data as a set of field value pairs in MongoDB, while collection is an organized store of documents in MongoDB, usually with common fields between documents. So another way by which data is being stored in MongoDB's document model is through collections. Collection is kind of a group of documents. And collections typically store documents that have similar contents. Example, look at these two documents now, the same collection, but with different ID. The user ID is seen, and the user ID is Daniel. The status A, and there's country here. And MongoDB collections do not, by default, enforce a single schema on a collection, so while documents can have common fields. So they are not required to have the same fields. So there's no issue having two documents where the first document has a country field and the second document does not have the country field. Now, the collections and schema validation. The document models used by MongoDB can enforce a schema if required. So the recommended approach is to do so using JSON schema. And the JSON schema gives you the opportunity to have a prescribed document structure to be configured on a per collection basis. It can also tune schema validation according to use case and can be used by any query to inspect document structure and content. Now we are going to data modeling and MongoDB. Schema design. So this kind of design comes from the needs of the application first. Therefore, the schema should evolve as the application change, because all the cause of all database models are their schemas. And when we are talking about schema design, it refers to the organizations of data into separate entities, determining how to create relationships between the organized entities and how to apply constraints on the data. So designers create database schemas to give other database users, such as programmers and analysts, a logical understanding of the data. So the core of data modeling is in the document model is to understand what does the data need by a query. So once that information is known, then you can begin designing the schema. And the data model in MongoDB is document-oriented. That is, it stores data as documents that tend to have all data for a given period in a single document. And it's flexible. You can store and combine any type of data while benefiting from sophisticated data access and rich indexing features. It's also dynamic. So data modeling with MongoDB. MongoDB supports the iterative and rapid development of an application. So this opens out many design possibilities or options. And MongoDB is designed for the application's usage pattern. It improves the applications itself. It improves the data model or the schema. So schema design considerations. Your queries and the specific data your applications requires is the schema design. So how your application reads the data, that's the read pattern, and how your application writes the data is the write pattern. So what are the relationships between your data, the linked or embedded? So these are the considerations to focus on designing your schema in the document model. So now schema design and link or embed. Look at embedded, the blog post now. This is my post, comment, and look at the linked one now. This is the blog post. This is the comment. Look at difference. So the question of whether to link or to embed your data is a critical factor to modeling in a document-oriented database. So embedded documents capture relationships between data by storing related data in a single document structure. So that is why you have the MongoDB documents, which makes it possible to embed document structures in a field or array within the document. So this denormalized the data models allow applications to retrieve and manipulate related data in a single database operation. So linking stores the relationships between data by including links or references from one document to another. And applications can resolve these references to access the related data broadly. These are normalized data models. Do I want most of the data's information embedded? That's your question. Do I need to search within the embedded data? How frequently will the embedded data charge? Is the embedded data shared or private? So firstly, if you are in issue or in the condition that you don't know the data information, should it be embedded? Most of the data's information shouldn't be embedded. So in this kind of case now, if the information is present in a single document, then retrieval will be faster than if it is in two documents or across two or more collections. So the frequency of the specific data and the size of the data must also be considered, as very large documents will not be retrieved as fast as tiny documents, even if those documents are in two separate collections. The second important question is to ask, do I need to search within the embedded data? In case we want to follow up to determine what you are searching for, and if it is only a fraction of the embedded data, Should only some of it be embedded and the rest linked? So, and finally, you should determine whether the embedded data can be shared or whether it is private. So indeed, this has will double checked with all stakeholders to ensure there are no doubts on this question, which is increasingly important in the age of both data and digital privacy. So I'm going to stop here and walk us through the MongoDB University. So MongoDB University is a university whereby you have the opportunity to learn about MongoDB resources. These are some of the resources that you can learn using MongoDB with Python. This will take you 1 hour. MongoDB creates, read, understand, and delete. So this will take you 2 hours. And MongoDB aggregation in Python. This will take you 1.25 hours. So MongoDB University gives you the opportunity to learn about MongoDB technology. And if you are operating or you want to create a database now, you move into www.mongodb.com. You try free, you sign in. You can either sign in with your Google or with your GitHub. So this is because I've signed in. That is why you have here with me. Let's go to manage your MongoDB account. Under here, this is when you want to create a database. You want to get support, connect and discuss with MongoDB community. And the education and training here can give you the opportunity to visit the MongoDB University. Just click on it. So you can learn MongoDB and advance your career. There are free large courses here to practice your skills with hands-on labs and quizzes. Then you earn MongoDB certification. This is Introduction to MongoDB, Atlas Essentials, Data Modeling for MongoDB, Self-Managed Database Admin. So you can learn any courses here. We have the live instructor-led courses that you can learn here. So let's go back now. So let me log out. Let me use so I click on next. So I can put in any password. I can log in now. Then I solve this puzzle. Then click on verify. Okay. Okay. Let me sign up now. If you don't have an account, you can sign up. So here you can have your email address, your first name, your last name, then the password, then the company name, then you accept. Then you can then sign up. This is because I already have an account. So let me just click in and log in with the Google. So this is now the MongoDB now page. which has different things that you can do. This one, when if I want to create a new deployment. So we have creating new cluster now, and we have different options. We have the serverless, we have the dedicated, we have the shared. Let's click on the shared cluster. Okay, the cloud provider, we can choose any one of them, and whichever region that you want to use. So the cluster tier is the MO sandbox. So this is because this project already has a free cluster. That's why it's bringing the here. That we have to select another cluster tier to add an instance. So let's choose serverless. So under this serverless now, you can view the pricing now. Let's view the pricing. If you want to write operations with the database, that is 0.9. But as a student, you have opportunity to some access to MongoDB. Let's click MongoDB, free access the students. So we have the student pack here. Let's go to the student pack. So these are the benefits. You are going to receive $50 Atlas credits, and you can claim your free MongoDB certifications, and you have to complete the DBA or developer learning path on the MongoDB University. So after you have completed the learning path, you complete this form to request your free certification code. So thank you, everyone.